Greetings everyone, welcome to today's video. In this particular video, we'll be tackling statistics and specifically the mean. In this these are videos of the part of a series that I'll be doing. I'll be doing a series in statistics, so I'll be tackling the mean, median, mode, standard deviation, normal distribution. And if there are other videos that will be like us tackle in statistics, then please let us know. Please like, subscribe. Make sure you light up that notification bell so that you can get an update on these videos in this particular series. And so without much further ado, let's tackle this mean that we'll be doing in today's video and get to know what the mean is. And so what's the mean? And before we tackle the mean, we'll be raising a question about a set, and a set is a list of elements. That's something you need to know. And you can have a set as 2, 3, 4. That's a list of elements that has integers as its, those are positive integers as its values or entries in the set. You can have pencil, paper, and eraser. That's a pen, pencil, and eraser. That's set with the stationery in the list. We can have an empty set where you have this is an empty set. We have also a set with small and capital alphabets, right? And you have a set where you can have all this combined in the set. But in GMAT, we'll be doing a set where you have these positive values or positive integers in a set. And so what's the mean? The mean is the sum of all entries in a set, all over the number of entries in that set. We have the set 2, 3, and 4. We have the sum of these elements, that's 5 plus 4, that's 9. And you can have the number of entries in that set are 3 entries. Entries are 2, 3, and 4, 3 entries, and you can have the mean as 3, right? What affects the mean of a set? Let's use 2, 3, and 4 for this example. Changing, modifying the values of the set by omitting or adding new entries in the set. For this set, you can add another entry, say 5, and a new set will be 2, 3, 4, and a new value, that's 5. Let's add this 4 together. That's 5 plus 5, that's 10, 10 plus 4. Yeah, this 5 plus 5, that's 10, 10 plus 4, that's 14. Divide by the number of entries, that's 4. And this should equal 7 over 2. This is 3.5. As you can see, 3.5 is greater than R3, and the mean increased by just adding a value greater than the mean. We can also add let's omit a value in 2, 3, and 4. You can omit the value 3, and you can have a new set as 2 and 4. Let's find the mean. That's 2 plus 6. 2 plus 4, that's 6. Divided by 2, that's 3. The mean hasn't changed. The values 2 and 4 are equidistant from the mean, as we'll see in the next point that I'll be mentioning. All right. We can omit other values to change the mean. In this case, it didn't change because it's an evenly spaced set, or the set is symmetrical. All right. So if we had to omit 2, for example, we have our 3 and 4 for the new set. Then we can have 3 plus 4, that's 7. Divide by 2, that's 3.5. The mean changed. All right. Now let's understand why these 2 and 4 didn't change the mean. In an evenly spaced set, the mean is equal to the middle digit when arranged in an ascending or descending order. That's the median. And same applies when the set is symmetrical. For 2 and 4, the set is symmetrical, meaning that the mean, given that it's 3, here the mean was 3, right? And the distance from 3, that's 1, and distance from 3, that's 1, right? Therefore, the mean equals to the median, and actually the mean won't change, right? Here, the distance from 3 is still the same, 1 and 1, right? And in a evenly spaced set, the mean equals to the median, right? And when the set also is asymmetrical, you can give an example of another symmetrical set. We have 3, and say add 2, we have 5. Minus 2, that's 1. Minus 3, that's 0. And can have a plus 3, that's 6, right? And our new set will be 0, 1, 3, 5, and 6. If you had to add this together, that's a 3 plus 1, 4, 4 plus 5, 9, 9 plus 6, that's 15. Divided by the number of elements in the set, that's 5. And you can have the mean as 3, as you can see, and the median should be the middle value when arranged in ascending order. In this case, the order is ascending, 0, 1, 3, 5, and 6, and the median is 3. The median equals to the mean. I hope you all captured that. If you haven't, please put in the comment section below. All right, let's do this question. Give this question a try, then I'll jump in. Right, a poll reveals that the average or the arithmetic mean of income of 10 households is 25,000. If 6 of the households have incomes $30,000 each, what is the average income of the other 4 households? Right? We know that household 1, household 2, added all the way to household 10, divide by 10 equals to 25,000. Let's think this in terms of the total value, and this also helps when answering these main questions. And therefore, the addition of this income of this 10 households then should be all the way to household 10 equals to 25,000 times 10. That's $250,000. All right. If 6 of the households have incomes 30,000 each, so we know that household 1 has 30,000. Household 2 has 30,000, all the way to household 6, 30,000. So we know that household 1, household 2, if you are to add this all the way to household 6, should be 30,000 times 6, and that will give us 180,000. All right. So we know that from household 1 to household 6, that's 180,000. Then we need to know household 7, household 8, household 9, and household 10. All this 180,000 plus all these incomes of household 7 all the way to 10 should equal to $250,000. Right? So the addition of these 4 values, does the addition of these incomes of these 4 households then should be household 7 to household 10 should be $250,000 minus $180,000, and that will be household 7 all the way to household 10 equal to 250,000 minus 180,000. That's 20 plus 50, $70,000. All right. Now we asked about the average income of the other 4 households. How do we find the average? We have the sum already, divided by the number of values. That's the number of households. That's 4 households divided by 4. So 7,000 divided by 4, that should be 35,000. Divide by 2, and that should be $17,500. Our answer is C. I hope you got that right.
You're watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstackamerica.com. Upstack America, we wake you up to the unlimited potential.
Let's try this other question. Please pause, give it a try, then I'll jump in. If the average, that's the arithmetic mean of X and Y equals to 60, this is the arithmetic mean. So we know that X plus Y equals to 120. And the average or the arithmetic mean of Y and Z divided by 2 equals to 80. So we know that Y plus Z equals to 160. What's the value of Z minus X? Seems like we have 3 unknowns, that's X, Y, and Z. And we need to find the value of Z minus X. Here's something we can, how we can find by just eliminating Y. X plus Y is equals to 120. We also know that Y plus Z is equals to 160. We need to find the value of Z minus X. How do we find Z minus X? We can eliminate the value of Y as I've mentioned, and we can rearrange this and have Y plus Z is equals to 160. Y plus X is equals to that's 120. subtract this from each other, and you can have y minus y, that's 0, z minus x in this case is equals to 160 minus 120, that's 40, and the answer is B. Right. Let's give this other question a try, and then I'll jump in. So let me list down the answer choices. That's A to E. So what is the ratio of the arithmetic mean height of students in class X to the average height of students in class Y? Given that we have average in class X is X bar and Y as Y bar, then we need to find X bar over Y bar. That's the ratio that we'll be looking for. And let's jump into the statement 1. The average height of the students in class X, X bar, equals to 120. What about the Y bar? We can't find the value of Y bar, and therefore statement 1 is not sufficient. Let's do statement 2. The average height of students in class X and class Y combined is 126 centimeters. I'm assuming you're thinking about doing X bar plus Y bar divided by 2. This is not acceptable in mathematics and statistics, and therefore we need to think about this question in terms of the total number of students in this class X and the number of students students in class Y, and say, sorry about that, N equals to the number of students in X, and P equals to the number of students in Y. Therefore, 126 equals N times X bar. That's the total number of values of heights in students in class X, plus P Y bar in Y, then N plus P, total number of students in both of the classes. Since we don't know the values of all these N, P, N plus P, so we can't actually find this ratio that we've been asked for in the first place, this X bar plus Y bar, right? And therefore statement 2 is not sufficient. Let's combine both statement 1 and statement 2. 1 wasn't sufficient, so A and D are out. 2 isn't sufficient, B is out. So we have to find if together they can actually be sufficient, or they can never be sufficient even if the statements are combined. So we know that from 1 that X bar is equals to 120. We only need the Y bar, right? And how can we find the Y bar? We know that 126 equals to, we can actually replace the value of 120 in this formula so that you can find the value of Y bar. So N times 120 plus P Y bar. N plus P. So this simplified is 120N plus P Y bar all over N plus P. Now, it has simplified most of the values, but you still don't know the value of N and P, and therefore we can't deduct the value of Y bar, and therefore we can't actually find that ratio of X bar all over Y bar, and therefore this is also not sufficient, and C is not our answer. Our answer is E. All right, pause the video, give this other question a try, then I'll jump into the video. All right, last year, each of the 200 students at a certain high school attended the school for the entire year. So 200 equals to the number of students. There are 8 cultural performances at the school during the last school year. What was the average arithmetic mean number of students attending each cultural performance? So we need to know the number of performances that the students attended over the number of actual 8 performances that are offered by the school, or that were done during that particular year, right? Let's down the answer choices. So statement 1, last school year, each student attended at least 1 cultural performance. For example, each student attended 1 cultural performance. This means that for they attended 200 cultural performances all over the number of performances that were given during that particular year, and you can have 100 divided by 4, that's 25. Or sorry, we have the number of students, that's 25, that attended each cultural performance. So 25 students attended each cultural performance, right? If each student attended exactly 2 cultural performances, then there are 400 cultural performances that were attended all over the number of offered cultural performances, and that will be 100, 200 divided by 4, that's 100 divided by 2, and that will be 50. As you can see, this at least one doesn't give us a specific value, and therefore we can't find the actual value, right? Like you can see here, we have 25, we have 40 different cases with the students attended exactly 1 or exactly 2, right? And therefore statement 1 is not sufficient. Let's omit A and D. We have fewer choices, that's B, C, and E. In an exam setting, you can actually make a clever guess using B, C, and E, right? You can have 2, set and 2. Last school year, the average number of cultural performance attended by student was 4. What does it mean by that? The average number of cultural performances attended per student was 4. So given that we have 200 students, right? Each student attended 4 cultural performances. We have 800 performances that were attended, and 800 performances attended divided by that 8, we have 100. And this 100 is the arithmetic mean number of students that attended each cultural performance. Therefore, 72 is sufficient, and you'll have our answer as B, right? Here's our final question. Give this question a try, then I'll jump in. In the first week of the year, Nancy saved $1. In each of the next 51 weeks, she saved $1 more than she had saved the previous week. What was the total amount that Nancy saved during the 52 weeks? So the first week, she saved $1. Second week, that's $2. Third week, $3, $1 more. Fourth week, $4, all the way to 52 weeks, that's $52, right? Now, a pattern that we need to notice, same as the one that you usually do when adding 1 to 100, is that if you had check the highest value plus the lowest value, that's when you have 53, and take the next pair, that's $51, and $2, that's 53. I hope you're seeing a pattern here. Drop down, you can have 50 here, and add up here, and you'll have $3, that's 53. Drop down once more, 49 plus $4, that's 53. Now, we're seeing a consistent value here, $53. And how many pairs of these values can you have? The number of pairs is 52 divided by 2, that's 26 pairs in this set, right? The upper values and the lower values, there's somewhere that these values are met, okay? And for this particular question, we'll have $53 times the number of pairs in the set, and that should be 606 times 13, 106 times 10 plus 3. This is 1060, 1060 plus 106 times 3, that's 18, 318. Add this together, 8, 6, 7, 3, 1378. C is our answer. And this is the sum of all the values in this set. That's set 1 all the way to 52. As you can see, it's a shorter way to find a sum of continuous or consecutive digits or integers from one point to another. All right. Thank you for coming and watching this video. Please subscribe, turn on the notification bell so that you can get updates on this series on statistics. Share the content. If you have any inquiries or questions, please post it in the comment section below and we'll tackle it. If you have any, if you'd like us to do any particular video that you're interested in, please put it in the comment section below and we'll take care of it. Thank you once more. Have a great day. Bye-bye.